All right, today we're going to talk about the Pythagorean theorem. I'd guess that you probably have heard of the Pythagorean theorem, probably have used the Pythagorean theorem, so we're going to move through this pretty quickly. First of all, the Pythagorean theorem is a theorem that helps you find the side lengths in a right triangle. And this rule, a squared plus b squared equals c squared, is the Pythagorean theorem. A and b are your two legs, and C is your hypotenuse, that side, that longest side that's across from the right angle. All right, so what this is saying that is if I take this leg and I square that length plus this leg squared will equal the hypotenuse squared. All right, so let's see if we can use that to find some missing links. Now we're going to get a little bit deeper. I'm going to guess that that's probably all you've done is just use the basic Pythagorean theorem. This video does get into some other stuff, and that's really what we'll spend most of our time on. But let's just get everybody on the same page. If the legs are 7 and 10, then the theorem would say that 7 squared plus 10 squared should equal c squared, the hypotenuse squared. So that's 49 plus 100 equals c squared. 149 equals c squared. So I have the square root of 149. Now there's two ways that we can answer this. We can leave this exact. Now normally I would try to reduce that radical, but I don't think 149 does reduce. So I'm going to leave it. But then the other thing that you can do is you can approximate that on your calculator. And so I'm going to do the square root of 149, and I got 12.21. So if it asks for a decimal approximation, that little wavy line means approximately 12.21. So either one of those are potential answers. Okay, so now let's try this another way. That's just your basic look for the hypotenuse. What if you already know the hypotenuse? In this case, the hypotenuse is 13. So I already know my C value. I know one of my legs is 5. We'll call that A. And then you're going to find the other leg. So I'm going to go look for B. This is going to look like this. 5 squared plus B squared equals 13 squared. So 25 plus B squared equals 169. Subtract the 25. B squared would equal 144. Oh, looky there. That's a good one. Because when I square root both sides, I get B to equal 12. Because 144 is a perfect square. So that one works out nice. Okay, so I was going to let you go ahead and try practice a couple of those on your own. Make sure you are very familiar with that Pythagorean theorem and how that works before we move on. I'll go ahead and wait for you. So pause that video and go practice a couple times. All right, here are my two answers. Hopefully you agree. If not, look back through my work and see where you might have gone wrong. And when you've got it figured out, then go ahead and move on. All right, so let's try some harder problems that aren't just quite so straightforward. This says, well, I got a couple of them. Let's start with this top. These are two different problems. So let's start with this top one with these 26 length sides and 48. That whole thing is not a right triangle. So you can only use a Pythagorean theorem in the right triangle. But what they've done here, you can see that they've dropped the altitude. And so that forms two little right triangles. And because this is an isosceles triangle, when you drop that altitude, it's more than just an altitude. It's also a median. It's also an angle bisector. It's everything. But that median is the important piece because that means this is the middle. We need to know that because we are going to use just like the half of this. We're going to use this triangle right here. And this right here is going to be half of the 48. So I've got a 24 for that leg. Looks like I'm looking for the other leg. So I'll have 24 squared plus x squared equals your hypotenuse squared. Okay, I don't know these off the top of my head. So I'm going to punch that in. All right, so I've got 576 plus x squared equals 676. Subtract the 576, and you have x squared equals 100. And so this one works out nice for us. X is going to equal 10. That's the height of that triangle. All right, so that wasn't super tricky, but you might have to like break down that triangle or do something, pick out a right. Remember, it's got to be a right triangle, so you got to find the right triangle in the picture. So let's look at this next one. It says the Hubble Space Telescope orbits 600 meters above the Earth's surface. So right here you can see here's the Earth's surface, and the Hubble telescope is out here, 600 kilometers. Now, the Earth's radius, which they show over here, is 6370. Okay, obviously this is not drawn to scale. It says use the Pythagorean theorem to find the distance x from the telescope to the Earth's horizon. So it's like looking and looking through at the horizon right here on the edge of the Earth. Round your answer to the nearest 10 kilometers. Okay, so I'm looking for this leg. So I know it's going to be like that leg squared plus this leg squared, which I know. Okay, I can do that. Let's write that. So that's going to be x squared plus 6370 squared equals, now think about this for a minute. It's supposed to equal the hypotenuse squared. Can you figure out how long the hypotenuse is in this picture? All right, here's the trick, is they told me this was 600, and they didn't really tell me this. They don't tell me the whole thing, but this is just a radius of the circle, and the radius of the circle is 6370. So whether I write it over there or I write it right here, that piece is 6370, this piece is 600, so it has a grand total of 6970. And I'm just adding those two values together to get the length of that. And then you would have to square that. All right, so I am not even going to write what that is squared. I'm sure it's huge. I'm going to go straight to my calculator, and I'm just going to take 6970 squared minus 6370 squared, and it's still huge even after I've subtracted. I get 8, well actually it's 8,004,000. Okay, but that's just x squared, so now I need to square root that. Okay, so now what I have, that distance from the telescope to the horizon, I have 2829.13. But we got to be careful with our rounding. You know how picky Math Excel is. So it says round your answer to the nearest 10 kilometers. Well, here's the tens place right here at that 2, but the 9 would round it up. So I would say 2830 kilometers after I got it rounded. All right, let's move on to something new that you probably have not seen at all. We're going to talk about something that we call Pythagorean triples. Pythagorean triples have happened a few times here as we work through these examples. It's when all three sides of the right triangle are whole numbers. So when I'm running it through my Pythagorean theorem, I get this nice pretty answer, like when I ended up with 10, or a 12. If all three sides are whole numbers, we call it a Pythagorean triple. And so the Pythagorean triples that we had previously, if you look back at your notes, let's find the ones that had all three answers come out nice. If you go back to that first slide of notes that we took, when we solved that problem and got a 12, look back at that one. Okay, that one came out nice. We got a 12. And the previous numbers that we were given were a 5 and a 13. So we would list that as it's a 5, 12, 13 triangle, and that's a Pythagorean triple. On the next page, we had another one come out nice, and we solved it and got 4. That's a 3, 4, 5 triangle. And that's a really, really common Pythagorean triple. And then this last one that we just got on this previous slide, when we got 10 for an answer, this is not, these are getting to be too big a numbers that you don't, these aren't that common that I would remember them. But we usually list a Pythagorean triple with the two legs and then the hypotenuse. The two shorter sides, and then that hypotenuse is always the longest. There's your two sides, and that's your longest side. Okay, so is check and see if these are Pythagorean triples. If they are Pythagorean triples, what it tells me is that I have a right triangle. If these three whole numbers work for for my Pythagorean theorem, I've got myself a right triangle. If they don't work in the Pythagorean theorem, then it's not a right triangle. When you do this, you got to make sure you keep your A and B, your smaller sides. So I got 16 squared plus 30 squared equals 34 squared. And then I'd go to my calculator and see what I get on that. 16 squared plus 30 squared. I'm just going to do that all in one shot. Oh, sorry, calculator wasn't on. 16 squared plus 30 squared equals, I get 1156. Okay, 1156. Is that the same? And it's like a question mark. Really, I should have a question mark on these. Is that the same as 34 squared? 30 squared, it is 1156. Okay, since they do equal each other, I'm going to say yes. That would end up being a Pythagorean triple, and it would create a right triangle. Okay, you try this one here. See if that would work. Okay, this is what you should have set up. They give them to me in the right order, so I don't have to do any rearranging. 28 is the longest leg. So you have 15 squared plus 20 squared. You'd have 625. And then I'm going to take 28 squared and see if I get the same thing. Ooh, I got 784. That is not the same thing. So no, that's not a Pythagorean triple, and that would not create a right triangle for those side lengths of a triangle. Okay, so then this is our last piece, and this is something probably totally new for you, but we can go a little bit farther than saying, hey, is that a right triangle or not a right triangle? I mean, that's nice, that's one thing to do, but we could go even farther and say, well, if it's not a right triangle, would it end up being acute or would it end up being obtuse? And if you think about this for a second, here's my right triangle. This is what this would look like. And this leg over here, this is my hypotenuse. Ooh, not what I meant to do, sorry. Undo. Okay. This is my hypotenuse. And that's going to be kind of my decider on whether this angle down here is a right angle, or if it's obtuse, or if it's acute. Think about it for a second. If I come over here and I make an obtuse triangle and it looks something like this, where it has that obtuse angle, what's going to happen to that hypotenuse as compared to what it was over here? All right, that hypotenuse is going to have to get longer. For that, if that angle opens up, then that hypotenuse is going to get longer. Whereas if that angle gets smaller, and it looks something like, okay, that's not a very good picture. Let me try that again. It looks like this, and then maybe it's a little bit less than 90. Then that hypotenuse, it's not really even a hypotenuse at that point, but that would get shorter because that closes up that angle. So what we're going to do is we're going to compare the c squared, the hypotenuse piece. We're going to compare that c squared to the a squared plus b squared. If the c squared is longer, that's going to mean that this had to open up wider. So let's put this in our notes. I don't know if you put all those little triangles. You don't have to have those triangles. But ultimately, for it to be obtuse, c squared is going to be greater than the a